So the next form of energy that we have is something called light energy. Light energy is the movement, it moves in waves, okay? Basically, it gives off any kind of light. A glow stick, a light bulb, a TV, the Promethean board, your oven, anything that gives off light is using light waves. And the way we measure it is we measure how bright it is. We measure it in watts. If you ever have a 100 watt or 100 watt light bulb, it's measuring the brightness of it, okay? Now, light and heat or thermal, light and thermal energy almost always go together. If something's lit up, it's probably got a higher temperature. Think of your light bulb. Every time the light comes on, you touch the light bulb, it's hot. Even your TV comes on, if you go up to the screen, you can feel it getting warm, okay? Your oven, the light comes on in the oven, it gets hotter. There are a few things that, very, very rarely, few things that light and thermal do not go together, okay? Can you think of anything that lights up but doesn't get hotter? There's about 3 of them that we've come up with. Think of something that lights up but does not get hotter. Yes, sir. Glow stick, perfect. You guys are getting ready to do Halloween and you all wear those glow sticks, you crack it open and all of a sudden it starts glowing. But does that thing get hotter and hotter? Do you feel it actually getting warmer when you have it in your hand or anything? No. So that's one of the few things that lights up but does not get hotter. Can you think of anything else? There's something in nature that you will see light up but doesn't get hotter. Jaden. A what? Okay, so he says a light post out there. Have you ever been up to a light post to touch that light?
No.
It's gotten hot. It gets hotter. Something in nature, like natural. Yes, sir. A what? Butterfly? Butterflies don't light up. Firefly. Firefly lights up, right? You guys have caught those. Some of you have seen them. You catch them, they get in your hand and they're glowing. Are they getting hotter in your hand? No. Anything else that lights up but doesn't get hotter?
Flashlight?
What kind?
Like just like a,
There's a certain one.
like one of those little, there's one that you press a button.
And it's not the light. Flashlight.
Flashlight?
Okay. Most of you guys are so young, you guys don't realize that most flashlights, they have a light bulb in it and that gets hotter. Most of what you guys see on your light bulbs that you're talking about, those are LED lights, okay? An LED light doesn't get hotter, okay? It just lights up. That's one of the few things, okay? But for the most part, if it gives light, it is light energy. And they travel in waves. Here's the key though. It travels without matter. In other words, it does not need a solid, liquid, or gas to travel through. Perfect example is the sun's light, right? The sun gives off light, comes to Earth, right? But it travels through space. Is it going through any solid, liquid, or gas out there? In space, is there air in space? No. Yet we still get light to us, right? The reason I say that is because our next one is the opposite. Sound has to have energy. It needs matter to vibrate. In other words, you have to have a solid, liquid, or gas. If you do not have a solid, liquid, or gas for sound to travel through, you won't hear anything. Okay? So you can hear me talking right now, right? So that sound of my voice is getting from my mouth to your ear by bouncing off of stuff. What's it bouncing off of to get to your ear? What solid, liquid, or gas is it bouncing off of? From my mouth to her ear, right here, right? How is it getting from here to there? It has to bounce off of something. It's like a pinball. It's got to bounce off of something, traveling in a wave to get to her ear. What's it bouncing off of? It's what?
Air.
Air, right. Just regular air. Air is a gas. You guys have been in the water, right? In the pool, and you go underwater with your friend, and you're on the other side of the pool, and you start yelling at each other. Can you hear them making noise through the water?
Yes.
You can hear them, yes. You may not understand them, but you can hear the sound because sound can travel through liquids. So we've said it goes through gas, it goes through liquids, solids.
Yeah.
If you're on the other side of that door, can you hear me?
No.
But wait a minute, that's a solid wall. How does sound get through a solid wall? Because it travels through the wall or through the door, through the glass, whatever it is. Sound can travel through solids, liquids, or gases. It will not travel if there's not a solid, liquid, or gas. For example, outer space again, right? If we're in outer space, there's no solid, liquid, or gas between me and you, right? If I were to yell something to you in outer space, would there be anything for that, those sound waves to bounce off to pinball to get to your ear? No. So you can be in outer space and yell all you want, nobody's going to hear you. That's why if you watch all those science fiction movies or whatever, and the planets blow up or the spaceships blow up and it's the big loud bang, kaboom, is that accurate?
No.
You won't hear anything in space because there's no matter, there's no solid or liquid or gas for that sound wave to bounce off of, okay? So light and sound are very similar in the way that they travel. They both travel in waves, okay? Sound needs something, light does not. That's why we can get light from the sun, but we wouldn't hear it. If the sun blew up, we wouldn't hear it. We would see there's no more light, but we wouldn't hear it. The last two forms of energy, last one, is the one most of you thought of when we were talking about, and when I asked you what is energy. Most of you said it's electricity, it's power. Well, here we are. This is one of those forms. It's just one of the forms. There's many forms, or 6 forms, but this is the one that most of you think of. Electrical energy is when the electrons of the atom move to other atoms. And we measure this in volts or in amps. Okay, if you've ever looked at anything to do with electricity, it's like a 220 volt, or my guitar has 15 amps, or whatever it is. Okay, that's talking about electricity. But what is electricity? The scientific definition is the movement of electrons. Well, what does that mean? That means this. You guys have all seen like Big Bang Theory, and you see this little symbol. Okay, that's the symbol of an atom. Okay, and what it is, in an atom, you have the nucleus right here, but then you have these little things on the outside. They're called electrons. And these electrons just sit there and spin around. Okay? They're spinning around in their own little orbit, kind of like a bunch of little planets going around the sun. All right? Electricity, the way electricity works is you have your little atom, and you have this electron that's spinning around out here, right? So he's spinning around and he's spinning around, but sometimes when we're talking about electrical energy, it gets too close to the next atom. So when this little electron, let's do it in yellow so we can, or blue. So I got this little blue electron spinning around, and all of a sudden that little blue electron gets too close and gets pulled into here. So now that electron moved to here. Well, here's a problem, because that other electron that was spinning around, it's too crowded. You can't have 2 of them in there. So he basically kind of gets kicked out. Which then, there's another atom. And he comes in, and now this guy, he gets kicked out. See how all these electrons are getting kicked to the next one, and they're moving from atom to atom to atom? Okay, that's what electricity is. Now this happens so fast, and it's so small, you can't actually see this, okay? But it's like playing leapfrog, just going, they're going as fast as you can think of it. I mean, think how fast it is when you flip on your light switch for that electricity to get to your light, right? You don't flip it on and then you gotta wait for it to jump across all those wires, right? It's almost instantaneously, because electricity is very fast, and these movement of electrons is very fast also. So again, Electrical is the movement of electrons. That's why they call it electricity, electrons moving. All right, so far so good. Everybody with me? The last form of energy is chemical energy. We just did chemical changes and chemical reactions, right? So here's what we're talking about. These chemical changes happen and it gives you energy. For us, if I asked you, oh, you're not looking very good, you need more energy, how do you get more energy? You eat food, right? I eat a hamburger, now I have the energy to go running, okay? There's times where you're like, I'm starving and I just don't feel like moving, and you need more energy. So you get an energy drink or an energy bar so that you can keep going. Why? Because that food, your hamburger, goes into your stomach, changes chemically into energy for your body and then waste that you get rid of, okay? So food, any kind of food that you eat is a chemical change that's releasing energy. Another one that we use is fuel, gas, kerosene, anything that you're burning, right? You're burning that stuff to get the energy. Your car, you put gas in it, right? No gas, no movement of the car. That gas is what gives your car the energy to go. It's because of what's in the gas. They burn it up, they chemically burn it, and boom, it gets to moving. The last chemical example that you might see is a battery, okay? Do not do this, but if you were to bust open a battery, there's two chemicals in there. And when those two chemicals mix, they make electricity, okay? That's why when your batteries die, it's because all the chemicals that are in there have mixed completely and there's no more electrons moving. There's no more electricity coming out of it, okay? Chemical is tricky. But if you know that it's the food you eat, the gas that we use, or fuel that we use, and batteries, that's about all you need to know in 5th grade. Okay? So far, so good. Everybody with me? I know I'm going kind of fast and we're doing this. There's one more part I want to do, and that what we're going to start doing now, and this is going to help us on our lab tomorrow, is we're going to take each one of these and we're going to talk about it a little more. Okay? So the first one we want to talk about is sound. Sound energy, we already talked about it. It must have a solid, liquid, or gas to travel through, right? We just talked about that. If you have no solid, you have no liquid, you have no gas, you have no sound. And I'm going to show you here in a second what happens. We talked about this. Sound is not going to be heard in space. In fact, let me show you. So this is, bottom line, here's the deal. I know it's an old video, but here's what we got here. He's got this little bell in there, right? Normally you'd see the bell and hear it going ding, 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 ding. But he's put this in a jar and they've sucked all the air out of it. So this bell is in a jar with no air. What do you think is going to happen? You're not going to be able to hear it. You'll see it. You'll see it just hitting away, hitting away, hitting away, but you don't hear anything. And then eventually he releases it and lets air get back in there, and you hear it go, tss, all the air goes rushing in, and then all of a sudden you start hearing it. So watch this real quick. This is not a very long one, and I know he's kind of old, but here we go.
Different kinds of experiments, and one of them is typified by this piece of apparatus here. This is what one might call an old faithful. The experiment that I'm going to do with this was first done in 1705, so it's a very old one. It was done by a man called Francis Hawksbee, who quite a lot of people think was the first and one of the great lecture demonstrators. And he did the experiment before the Royal Society. We have a clockwork mechanism that will ring the bell, but we've pumped out all the air from this bell jar, and so when I start it running, you won't be able to hear it. You can see
it?
The hammer hitting the bell.
You should be hearing ding, 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 ding.
It's got a life of its own, this sponge. I've got to hold on to it.
But it's not working.
You can see it striking the bell, but because there's no air inside, you can't hear it. Now I'm going to let the air in. And as we let the air in, Now I think you can hear the bell quite clearly.
Okay. So now
And
you
that's a
can hear
very
it.
nice experiment to
So that proves to you that sound has to travel through either a solid, liquid, or gas. There, it wasn't traveling through anything. There was no gas there. It was in a vacuum. There was nothing for it to travel through, so that's why there was no sound. As soon as you let air in there, so that those sound waves are able to vibrate and bounce off of all those little air molecules, then you're able to hear it. Next question is, which one of these would sound louder and why? So, all right, so I have, these are called tuning forks, and these tuning forks make noise, okay? You may have seen them last year in lab or whatever. You hit them and they make a noise. So my question, since we measure sound in pitch, right? Higher pitch, lower pitch, right? Which one of these is going to be a higher pitch and why? Which one is going to be a higher pitch and why? What do you think?
The higher,
Which one? The longer one or the smaller one?
the longer.
The longer one will have a higher pitch. How many of you agree? The longer, the higher. We don't know yet. How many of you say the smaller, the higher? Well, let's find out. Which one has the higher pitch?
The longer one, small one, little one.
Small one.
Okay, some of you aren't. High pitch. Ready? Some of you are still not. Ready? Which one's higher sounding? Small one, much more. Explain to me why. Why does the smaller one have a higher pitch? Emma?
It don't have a lot of room to vibrate.
Right. So when we're talking about this, we said sound moves in waves, right? So if I took this, this is a slinky. Stand up there, Angel. This slinky, I'm going to show you how waves move, okay? Come here and hold this for me right here. All right, so he's going to hold that, and I'm going to show you there's two ways that, kind of hold it up so the camera can see. Okay, so there's two ways that waves move, all right? All right, let's try to keep it still. Don't move, don't move. All right, so one way is that it goes back and forth this way, right? So if I go like this, can you see how it goes?
It kind of looks like M.
See how it's going back, forth, back, forth. That's one way waves can move, right? Another way is if it goes up and down, like a wave,
Oh, wow.
like, let's see, all right, hold on, let's try again. Right? Like at the beach, waves kind of go up and down, right? So if I did that, look how long it takes, right? Down and back. Down, back, down, back, down, back, right? Because it has so much longer to travel, right? So the longer it is, the slower it is, right? Guess what? The slower it is, the lower the pitch. Now watch if I did the same thing with a short one, right? Oh, no, don't let go. Hold it. Okay? Ready? Real short. Boom, 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 boom. Real fast, right? So it's going real fast. The faster it is, like, the higher the pitch. Okay? So the pitch depends on how fast something is vibrating it. If it's got a long way to travel, it's going to go real slow. Slower it is, the lower it is. If it's high pitch, that means it's going real fast. Real fast. The faster it goes, the higher it is. Okay? Slower, lower. Kind of get that? Slower, lower. That's why it's the same word, other with an S. That's why when you have two instruments like this, you have the double bass, right? It's the big tall one, and when you hit it, it's dum, dum. Why? Because it takes forever for that string to vibrate. It's real slow, which makes it real low. The violin is real small, right? And that's that real high squealy pitch, right? You make it, you pluck on that and it's just got to go that fast. Just up and down this quick makes it a higher pitch. Any questions?